video is about how to use similar triangles. Similar triangles are triangles whose angles are congruent. That's really basically it. And this is very similar to what we did all the way back in chapter 2 when we were talking about similar figures. So we're going to be using proportions again. And proportions are something that we covered in 7th grade. So you might need to go back and hit a review on proportions if you're a little confused on that. There are videos up available for you if you want to look at proportions. And so again, we're using similar triangles to solve math problems. So how do we tell if things are similar triangles or not? Well, basically, just like we did before with similar figures, we just check to see if the angles are the same. So in number 1 right now, we have 2 triangles, and our job is to tell if they're similar. So we have here is 122 degrees, this is 30 degrees, this is an unknown. So let's find out what y represents. How do we do that? Well, we know for a fact that all those interior angles should add up to 180. So being that said, we can subtract the 122 and the 30 from this, and we find out that that y is 28 degrees. Now let's do the same thing with a smaller triangle. So we're going to go 180, we're going to subtract 122, and then subtract 28. And we find out that this missing x happens to be 30 degrees. Well, stop right there. Notice that all three of these match all 3 of these. It simply means that all the angles match, therefore that this is similar. So yes, it is similar because all angles, well, let me rewrite that, not all angles, but all corresponding, that's the word we're really wanting to use, corresponding angles are congruent. All right, so that's really the terminology that we want. Correspondent. There we go. I had spelled that wrong. So these 2 correspond with one another, and they are the same number. Same thing with this. Same thing with this. That's really all you have to do to find out if 2 triangles are similar. Check to see if their angles are congruent. So why don't you try number 2, 3, and 4 on your own? See how you do. So what you should have got for numbers 2, 3, and 4 are no, no, and yes. All right. The simple reason is the corresponding angles right here were not congruent. They were not the same. Same answer could be said for number 3. As for number 4, the answer is yes because the corresponding angles are congruent. Now, after we understand that the triangles are similar, we can use this information to do something that's called indirect measurement. So here we have 2 similar triangles. They're similar because I've told you they're similar. All right, and your job is to find x. So we have a small triangle here. I have a 20 foot by 40 foot, and then we have an 80 foot by x foot. So how do we figure out what x is? Well, we set up a proportion. We set up what we know to be true. All right, so we look at this. We have a small triangle into a large triangle. So we're going to set up a proportion. And we're going to say this 40 foot is to 80 foot. These 2 are both the long sides of their corresponding triangles. So we're going to put them together. So this 40 and this 80, they come up there. And we're going to equal that to this 20 over x. And here's the reason why we do that. These 2 sides, this is my long side of my smaller triangle, this is my long side of my larger triangle. So we put those together in our proportion. The small over the big. It's okay, we could have done it the opposite way, but it's just easier to do small over big. Now with that concept, we do the same thing, but we do it with the other corresponding sides. So this 20 foot corresponds to this x feet, and we do the same thing. And since this represented our small, this is our small. This is our big, this is our big, which is what's on top stays on top. What's on bottom stays on bottom. Now that we have that, we can cross multiply and divide. This would give us 40x. This will give us, let's find out, 80 times 20 gives me 1,600. Divide by 40 on both sides, and I get that x is equal to 40. So that length here is 40 feet. All right, let's do some more problems like this. So let's go ahead and do number 5 together. In this one, it says you can use similar triangles to find the height of a tree. Triangle ABC is similar to triangle DEC. What is the height of the tree? So it's telling me right now that this triangle that I'm circling, this kind of is not the same, but similar to this big one. So what our job is to figure out the height of the tree. So what we know is this: the distance from here to this man right here happens to be 6 foot. That's what we know. And that is the long length of the small triangle. We also know that the distance from this all the way to the tree is going to be a total, check this out, not 9 feet, but a total of 15 feet. Here's the reason why it's 15 and not 9. We know from here to here is 6 because of this measurement, but then from here to here is an additional 9 feet. So all together, this is 15 feet. So we know the small triangle, this length is going to be 6, and this long length here is going to be of the base, to be more specific, is going to be 15. Now that we know that, we can discuss the difference of the height. So the height of the small triangle is to 4, and the height of the large triangle is x. Now that we've set up a proportion, it's just a matter of cross multiplying and dividing again. This would give us 6x is equal to 60. How did I get that? I did the butterfly effect. Okay. And now I can divide by 6 on both sides, and I get that x is equal to 10 feet. So that tree is 10 foot tall. There's going to be several problems that are in your assignments that go along with this, and again, it should be fairly easy if you remember how you did similar figures. It's the same concept, but as always, you know how to find me, and I will see you in the next video. Bye bye.